Hello, 8th graders. We are heading into lesson 3, and the main focus on this lesson is to learn about what irrational numbers are. You see this comic right here. It'll make a little more sense towards the end of the lesson, but take a look at it and start again when you're ready. In your first activity here, you're going to find a positive solution to each equation. We'll do number 1 together. X squared equals 36. That really means x times x equals 36. So what number times itself gets you 36? And I would know that 6 times 6 equals 36. And so that means that x needs to equal 6. Go ahead and try the rest and start again when you're ready. In number 2 here, 3 halves times 3 halves. If I multiply across the top, multiply across the bottom, I get 9/4, and so my x would equal 3 halves. In number 3, if x squared equals 1/4, that means that if I have 1/2 times 1/2, multiply across the top, multiply across the bottom, I would get 1/4, so x equals 1/2. In number 4, if x times x equals 49/25, I would have 7/5 times 7/5, multiply across the top, multiply across the bottom, and I would get that 49/25, and so my x equals 7/5. In activity 2 here, we're going to be going back to the grids that we've seen before and drawing some squares. They want us to draw squares with the vertices aligned to the vertices of the grid. And so we're going to draw these together, and then you will do some work with them. So there's our first square. Here's our second square. And here's our third square. This one's tilted, but the corners of the square are on the vertices of the grid. Now you're going to go ahead and try number 2. Label the area of each square, label the side length of each square, and then we'll start again when you're ready. For our first square, the area would be 4, the side length is 2. That one's pretty easy to count units. The second one, area is 1, and the side length is 1. And then this last one, the area is 2, and I found that by finding the area of my big outer square, which was 4, and then subtracting off each of those corners, which was 2, so that leaves me with an area of 2. Now the side length on this one, I'm thinking to myself, what number, remember length times width equals area. It's a square, so these two are the same, so I'm going to call them both the side length. So what number times itself gets me 2? That's not a nice perfect square, and so the side length is going to be the square root of 2. And that brings us to C, the equation that shows the relationship between the side length and the area. We just did that up here. I could also rewrite it as side length squared, or s squared, equals the area. In activity 3, we're focusing on the equation x squared equals 2, which really means x times x equals 2. And we're deciding if each of these, or if any of these, could be a solution to that. So looking at our first one, if x equals 1, then 1 times 1 equals 2. If we plug that in for x, does it make our solution or our equation true? No, it does not. So 1 is not a solution. We could go on 1/2. What does 1/2 times 1/2 equal? 2. No, 1/2 equals 1/4. So that one doesn't work either. Try the next two and start again when you're ready. In our third one here, 3 halves times 3 halves, that would equal 9/4, which is not equal to 2. And the last one, 7/5 times 7/5, that would be 35/25, and that is also not going to be equal to 2. And this brings us to the idea that there is no nice number that is going to make this equation true. So the only solution to this equation would be x equals the square root of 2, because the square root of 2 times the square root of 2 is going to equal the square root of 4, which is 2. So the only solution is what we call an irrational number. We're going to skip the rest of this activity, but you are going to take some notes. So get ready for that, and here we go. The difference between a rational number and an irrational number is really pretty simple. A rational number can be written as a fraction, so one number over another number, while an irrational number cannot be written as a fraction. Here's some examples of rational numbers, something like 1/2, clearly written as a fraction. 451 over 65, it's an improper fraction, but it's still a fraction, so it's a rational number. 1.7, I could rewrite as a fraction. That would be 1 and 7/10 or 17/10. 0.3 repeating. When you see the repeating sign, it can be written as a fraction. This would be 1/3. 0.2 repeating, that would be 2/9. So whenever you see that repeating bar, it is a rational number. And just because we see a square root symbol doesn't mean it can't be rational. The square root of 25 is 5, and I could write that as 5 over 1. I could write it as a fraction, so it's a rational number. Here's some examples of irrational numbers. Square root of 2, which we just saw, we cannot find a number that you multiply by itself to get 2, so the square root of 2 is irrational. The square root of 10 would also be irrational. There's not a nice number that multiplied by itself gets you a 10. If you put these in a calculator, you would get decimals that go on forever without repeating. That's another clue that it's an irrational number. So that brings us to pi. We all know that pi goes on forever without repeating, and so that is also irrational. We cannot write it as a fraction. And then lastly, I put this example because irrational numbers can also be negative. So the negative square root of 5 could be or is irrational. So now that you've learned what an irrational number is, I'll leave you with this comic again. It'll make more sense now, and hope it makes you smile a little bit. All right, have a good one, guys.